I am Vibhor. Our project is a binary classification problem of classifying a tumor into two different class labels, that is benign and malignant. So to collect the data set, we have used UCI machine learning repository for data collection. So what does our dataset all about? So our dataset contains 11 columns that are features or attributes and 700 rows that contains the participants in the survey. So these are all the 11 features that we have in our dataset. Some of these are sample code, clump thickness, uniformity of cell size, uniformity of cell shape, marginal addition, and etc. So our class is contains two things. Two our class label is 2 for benign and 4 for malignant. Now let's come to data pre-processing and analysis part. Here this is the header containing 5 entries in our dataset and showing all the features. Here based on this header we can clearly see that this last column, that is 4 for malignant, contains all the NaN values which are completely irrelevant. So we have dropped this column. This was our first observation. Our second observation was unknown values that were marked as question marks. Uh, so the number of unknown entries are 16, and these are all the indices of these unknown values. This code is finding all the counts of the different values of the bare nuclei attribute. From this count value, it is clear that 1 is repeated most of the time, that is 402 times. So we have replaced this unknown value with this mode value, which is most relevant. Now let's check what are the missing values in the dataset. So from here, the column shows that there are no other missing values. So therefore, we have completely pre-processed our dataset. So let's come to the normalization. So normalization is very necessary. In this case, we are using normalization function as given a data point, we are subtracting it by the minimum value from the given values of the data and dividing it by the maximum value minus minimum value. So this is the entire function for normalization. So we have printed this header after normalization. Now let's come to the visualization part. First, in order to have the analysis of the similarity between the or associativity between the data points, let's plot the heat map. So heat map is a very good way of is a very good visualization of finding the similarity of between the two pair of attributes. Here, the first line computes the correlation between the every pair of features. So this heat map shows that, suppose let us the example of class. So this is a class, and this class is very much highly correlated with three attributes that are bare nuclei, uniformity of cell size, and uniformity of cell shape. That means these three features are very much relevant with this class. So we must select them. But we'll do further analysis for final selection of these features. So after digging deeper into the dataset, we found that uniformity of cell size and uniformity of cell shape itself are having 0.91 correlation. That means they are highly correlated. So we must choose either of them, right? So while doing feature engineering, we'll select features that are very less correlated and eliminate all the highly related features. Now let's come to the count plot and pie plot. So using count plot and pie plot, it is clear that we have enough entries for both the class labels. For benign class, we have 458 entries, and for malignant class, 241. So these are significant values. So our model is not suffering from class imbalance problem, right? So this is here the count plot, and this is the pie plot that this is a pie chart that contains 34.48% of malignant entries and 65.52% of the benign entries. This is what the description of our dataset containing all the count, mean, and standard deviations of all the features. This is the violent plot. So violent plot is a method of plotting numeric data. So we have selected this plot because we are mostly dealing with the numeric features. So it is like one of the most relevant graphs to show. It is actually very much similar to box plot, except that it also shows probability densities of data at various values. So this is the box plot. This box plot shows this is the interquartile range, and this is the 50th percentile, that is a median. This is the 25th, and this is the 75th percentile, and all these dots represent the outliers in our data set. This is a joint plot. So from the heat map, we have already found out that uniformity of cell shape and uniformity of cell size are highly correlated. So this is how we have plotted their correlation. So from this joint plot shows the joint plotting of these two features. And this straight line completely shows that they are very much highly correlated. So we must select either of them. Now let's come to the feature selection, which is a very important part. Here, as uniformity of cell size is very much correlated with uniformity of cell shape, so we are manually dropping this feature. Now, in order to select all the other important features, we are using select k-best method, that is selecting best 5 features, that is completely based on our experiments out of 10 available features in our dataset. This method actually finds out the fitness scores of all the features and then selects the ones with the highest scores. So here all these 5 features are the ones that have the highest fitness scores, right? So now this is the machine learning model. First of all, we have shuffled our dataset for better results and remove overfitting. So we are dividing our dataset. Now, training set contains 70% of all the records and test set contains 30% of them. Using this train test split, we are splitting our dataset randomly. We are shuffling that first two. So, as a model, we are using random forest, which is an ensemble-based model that fits a number of independent decision tree classifiers on various subsamples of the datasets. Actually, it's a bagging-based ensemble models, uh, which usually does better than all the other available models. We have also tried several other ensemble methods like Adaboost, which is based on which is a bagging based model. But in every case, random forest outperformed, and it was giving us better precision, recall, and accuracy values. So now in this case, in this code, we are making an instance of random based classifier. So we are using scikit-learn library for importing our datasets. We are now fitting our train set and now predicting our testing set using random forest classifier. Now let's come to the evaluation part. So how is our model actually behaving? So let's dive into it. First is the feature importance. Here we are now doing analysis of how each and every selected feature is contributing towards prediction in the model. So this is very much essential, and we are using the visualization method so that we can be sure that the features that we have selected are actually contributing towards the prediction and better accuracy of the model. So this is the graph. This is the plot that shows all the 5 selected features. This clearly shows that marginal addition is contributing the most towards the prediction, and followed by all the 4 other features. Now let's come to model evaluation. For evaluating our model, we have used various scores. First one is the accuracy score. So while calculating accuracy score, we are getting 97.14% of the accuracy, and with a precision of 96.71%, recall of 96.71%, and F score is also 96.7%. So F score is 2 times of precision into recall divided by precision plus recall. So based on these scores, we have computed the confusion matrix also, and visualizes for better understanding. Here, the entries of confusion matrix are as follows. First of all, this 140 denotes the true positive, 3 is false positives, 3 is false negative, and 64 is true positive. So this is how we have computed confusion matrix. So now concluding our project analysis, we are getting a very good accuracy of 97% with using best practices of making a machine learning model. Thank you.